So I am Alfredo Faubel, and our company is called Carbon BioCapture. So basically our technology is based on microalgae. These are naturally occurring microalgae, which we source from the local environment where the emission is located. And we divert the gases from the flue gases from the smokestack, and we pipe them into photobioreactors. This is where the microalgae consume the CO2 as well as the SOx and the NOx and release oxygen by the process of photosynthesis. And as a result of that biological activity, they multiply and you obtain biomass, which you can use for a number of purposes. So as you know, in the cement manufacturing process, several hundred kilograms of CO2 are released for every 1,000 kilos of cement. This has to do not only with the combustion, but also with the chemical changes in the minerals that are treated in the ovens. These emissions would typically go to the atmosphere, and we have found a way to actually capture that through a biological process using microalgae. So in our discussions with a number of cement companies, one of them suggested that we apply for this Innovandi Open Challenge, which frankly we did not know about until that moment. And so we were very excited to realize there is an interest in the industry to do something about the emissions, and we felt that our technology was a very good fit and had not been explored before by the member companies. So it's been a very fruitful discussion because we've had many meetings online, and we've had a number of exchanges of technical information. There were lots of questions. I mean, this is a relatively new technology. They were not familiar with it, and there were some challenges that we had to overcome. But we found all the members we interacted with extremely interested and proactive and helpful. So it's been a wonderful experience. So the technology is based on the use of non-genetically modified microalgae. That means we use native strains that are found right where the emissions are generated. So each of the member companies that we're working with sampled the local water in the vicinity and within the premises of their own factories. They submitted us their samples of water, which we sent to our lab in Chile. And we actually discovered that there were suitable strains in each one of these venues. And so now we have basically identified the strains. We have actually succeeded in adapting them to high concentrations of CO2 not found in the atmosphere, so they actually survived. And we have assessed their kinetic behavior. So we know for a fact that now we can actually deploy these strains and subject them to the actual flue emissions of a cement kiln.